Welcome, everybody. It's 4 p.m. and this is the third Zürich NGINX Meetup. Thanks a lot, everybody, for joining. Thanks to all of you who are watching on YouTube, where this talk will be posted right after when it finishes. And my name is Adrian Kosmaczewski. I'm developer relations at Vision. We are the organizers together with F5, the company behind NGINX. We are organizers of this meetup. And today we are going to have a great talk by Marc Merzinger from ti&m about auto HTTPS with NGINX Ingress and Cert Manager. And of course, we're going to have time because nobody else came up with another topic for today's meeting. We're going to have time for some question and answers, so feel free to ask them. If you look on your screen, you should see a Q&A box at the bottom, as well as a chat window. Feel free to pose your questions there. I will be moderating them, and then at the end of the presentation, Marc will answer some of them. Just a few words about Vision. We are the organizers of this meetup, of course. The name is pronounced Vision, just like the word, like the I, hence the I in the logo. And we are the DevOps company. We're located in Zurich, and we are Switzerland's leading DevOps, Docker, and Kubernetes partner. We offer 24/7 support to our clients. We are certified in various ways, which our clients appreciate. And we have also been the first company in Switzerland to be certified Kubernetes service provider. We are partners with many companies, some of which you recognize the names around. And we also have created our own platform as a service called Puyo. We have created a few open source projects related to Kubernetes, Project Sin, which allows you to manage a fleet of Kubernetes clusters from one central location, and KDAP, which is a Kubernetes backup operator. All of them open source, free for you to use on GitHub. Very well, enough about Vision. I now pass the stage and the screen to Marc, who's going to talk to us about HTTPS with NGINX Ingress. Marc, I stop sharing the screen, and the screen is all yours.
Thank you, Adrian. Okay, I will start the sharing. Okay, I hope you can see my screen.
It's perfect. Thank you so much.
Great. Welcome. Then, yeah. Welcome from my side as well. My session is about auto HTTPS with NGINX Ingress and Cert Manager. And before I start, a few words about myself. I'm Marc. I'm a software engineer at ti&m. I'm part of the cloud engineering team. I'm involved in many of the cloud projects, mainly on Azure and GCP. I design the environments. I automate it using GitLab or Azure DevOps. And then, of course, we run it. I'm still a software engineer, but most of the time I'm involved with cloud infrastructure. And my hobby is my private blog. It's cloudjourney.io. Okay, one disclaimer at the beginning. Everything that I will show runs on Kubernetes, so I will assume a little bit of Kubernetes know-how, although that I will cover the basics, and I will leave aside some of the concepts that are underneath it. But overall, the underlying platform is Kubernetes. So I will start with Ingress and Cert Manager, and then I will show us a short demo on how to do auto HTTPS. First of all, what is Ingress? In Kubernetes, it's a cluster. You need a way to get traffic into the cluster. So you need to be able to expose the services that run inside your cluster. And therefore, there's Ingress. In the end, it's just a specification or an API object inside Kubernetes that allows you to grant external access to the cluster. It is, it provides the basic load balancing on layer 7. So it's the HTTP protocol underneath it, SSL termination, what we will see, routing and more. It depends on the implementation. On the right-hand side, we have an example of how an Ingress object, a very basic Ingress object could look like. We have two hosts in this list, the api.dev.mme/lab.io, which routes all the traffic coming in under / to the app backend, and everything on .www and so on to app frontend, which is the most basic Ingress resource that you can have. And it tells Ingress to map traffic from a given host to a specific backend that runs on Kubernetes. So as I said, Ingress is just a specification, so you need to have an implementation of it. You can see a reference here under spec, Ingress class name, NGINX. It references an Ingress class, which is spec'd by an Ingress implementation. And the Ingress implementation itself is called an Ingress controller. There are lots of Ingress controllers out there. All of them implement the Ingress specification, but most of them also have more features available that are outside of the vanilla Ingress. So in the end, the Ingress controller watches the resource that I've shown to you and configures then a reverse proxy to do all the routing in behind. For this meetup, I have like 3 NGINX Ingress controllers that we could use. I will use the open source community version. It's quite important to note that those that, like, at least from my point of view, the most popular NGINX-based Ingress controllers. But there's a big difference between the open source community Ingress and the official from NGINX Inc. or F5 Ingress controller. So a migration between those two is not that easy. So if you ever want to upgrade, start with the NGINX Inc. version of the Ingress controller. And also, of course, NGINX Inc. they have a plus version for this Ingress controller with even more features. But for the sake of this demo, I will rely on the open source NGINX Ingress community version, which is sufficient because it just implements the Ingress specification. If you want to learn more about those Ingress, I inserted 2 links to find the official one and the community. Okay, so this would be the first part. With an Ingress controller, we can get traffic into the cluster, but now we need to make it end-to-end encrypted, at least until it hits our Ingress controller, and therefore we need an SSL certificate. And that is the place where Cert Manager comes into the game. Cert Manager itself is a CNCF project. It was originally created by JetStack, and it allows us to automate the certificate management. We all know it. Managing certificates by hand is quite tedious and error prone, and so it's a good idea to automate this. And Cert Manager allows us to do this using Kubernetes native mechanisms that I will show later, and it supports different integrations. So you can have your own private CA, you can use Let's Encrypt. We will do this in this session. You can also use like an AWS key management system in the background. Okay, so how does it work under the hood? In the end, everything starts with a CA. So the one that is responsible for issuing your certificates. And Cert Manager provides the concept of issuers. These can be, in Kubernetes terms, namespace or non-namespace. If they're non-namespace, they're like cluster issues. But in the end, they represent a CA. In our case, this will be Let's Encrypt. Then we have a certificate, which then represents our TLS certificate that is used to do SSL termination. And this one references an issuer. How this looks like is something that we will see later. But the certificate is just like a representation used by Cert Manager, and it creates a secret, which is just the cert and the key that can then be used or read by the Ingress controller to do the TLS termination. And all the stuff in behind, for example, creating a certificate request or doing the ACME challenges, is everything done by Cert Manager. So it uses custom resources there as well, like a challenge or an order, but it's hidden from us. We can use some hooks at certain points, but for the demo, we will see that almost everything is hidden from us, which is quite convenient to get HTTPS out of the box without having to deal a lot with certificates and issuing and ACME challenges and whatnot is needed to do this. Okay, so this is basically how Cert Manager works. If we put them together, Cert Manager and Ingress, we need now two files. On the left-hand side, you can see, again, an Ingress spec. And on the right-hand side, you can see an issuer. The issuer, you can see that we are referencing the ACME staging. No, it's a production server from Let's Encrypt with my email as a contact. And the solvers is just a reference to our Ingress class. And this is just a representation of where Let's Encrypt can create an ACME challenge against. And then on the left-hand side, we have our Ingress. It's the same as previous, just with one enhancement. We have a TLS section where we specify a host and a secret name. And this section is quite important because it tells then later NGINX that the secret name app-cert contains the certificate for the domain app.dev. and so on, that it can do the TLS termination in the end. The remainder for the rules, it's just the same as I've shown. So as soon as we have a Cert Manager installed in our cluster, we create the issuer and the Ingress. It is able to resolve from the annotation Cert Manager.io/issuer Let's Encrypt prod that it has to use the Let's Encrypt prod issuer to create a certificate for the app.dev.mme-lab.io domain. And everything else is done by Cert Manager. The only thing that we have to ensure is that, of course, we have a DNS record in this case because we are using the HTTP server to the IP of our Ingress. That brings me to the demo because I will show all the details of this. The demo setup is quite simple. I have a Kubernetes cluster already running. I have NGINX Ingress installed on it and Cert Manager. And we will have two applications, a backend and a front end, each one listening on their own domain. We want to expose it to the internet, to the users. And then we want to issue certificates for those domains because initially they will be just HTTP and we want to have HTTPS in the end. And that's something we will do via Cert Manager. Okay, so I will switch to a different screen. Okay, I hope you can see my screen.
Yes.
Great. Okay, now this is the code that I use. So this is the issuer YAML. I have a Let's Encrypt staging issuer, and I have a Let's Encrypt prod issuer, just to demonstrate that you can test, of course, the stuff without using Let's Encrypt prod, and just to make sure that there are no mistakes in the implementation. My applications, it's just quite simple HTTP echo for the backend, and the front end will be a plain standard NGINX. And of course, an Ingress. But before I go into the details, I will show you a little bit what's in my cluster. Here I'm connected with my cluster. I have Cert Manager installed and NGINX Ingress. And if I do this, to list everything that is running inside my NGINX Ingress namespace, I can see that there is my Ingress controller running. It's not HA, but it's not important for this demo. And I have an external IP. So this is a public IP. This is an AKS cluster in the background. And I did the DNS setup previously. So if I do an NS lookup for W, we end up at our Ingress controller. So now I can show you everything that's running inside of Cert Manager namespace. It's a basic Cert Manager installation. HA, at least from my point of view, is not that important for Cert Manager, as certificates do not expire every second. So again, this is just a standard installation that I did with Helm, and so Cert Manager is now able to to listen to the issuers, so the staging and the prod issuer, and then to listen to the Ingress resources that reference them. First of all, I will create the issuer inside the cluster. I already did this. If I do a kubectl get issuer, you can see that Let's Encrypt staging and prod are there. And now we can deploy the application. It's as simple as kubectl apply one for the backend and one for the front end. And you will see that now my front end and backend, they spin up. They are running as 3 replicas each, and they are exposed inside the cluster, so they are not available externally with a service object inside of Kubernetes. So now the next step would be to make them available to the outside. Before I do this, I want to show you that I have to find the right combination. I want to visit my domain. It's http www.dev.mme lab.io. You can see that we get a 404. That means we are pointing with this domain to the Ingress controller, but the Ingress controller doesn't know who serves the traffic for this host name. That is because I haven't deployed an Ingress yet. So if I do kubectl get inc, inc is just abbreviation for Ingress, you can see that there are no resources. So that's the reason why we have a 404. So then the first step is to deploy my Ingress resource. The Ingress resource is like the one that I've shown in the slide. I will listen on the 2 hosts, one for backend and one for front end, and I will redirect the traffic directly to the implementation or to the services and then to the pods. And to create this, I will apply it as well. And now if we do kubectl get inc, we will see that the Ingress class NGINX is responsible for the Ingress named app for our 2 hosts. And this is the public IP that is serving those 2 host names. And if we do now a refresh, we should see something, and we see nothing. Okay, the demo gods. Maybe it's just this integrated browser. I'm not used to this one. Can you see my second screen? I just opened it in a pop-up window.
Nope, not really. We just see one screen.
Then I will have to stop sharing and switch to my browser. You can see my browser now?
Yes, we can see your browser. It says welcome to NGINX, yes.
Okay, now, so unfortunately, my cache was still there. So now it's unsecure, of course, but it's now available. And if I do this for the API, probably I have still my cache. Yeah, of course. So, I used HTST. So the certificate pinning. that's the problem if you do it before the demo and then you forgot to clean this. But as you can see now, it's publicly available, but it's still not a valid certificate. So now let me go back to the code. The next step would be to switch to Let's Encrypt staging. So for this, we use the same Ingress specification, but now we have the annotation for the Let's Encrypt staging issuer. You could do a kubectl patch or whatever. It works similar, but for this case, I will just apply whole new Ingress object. I will just do it by kubectl apply. If I'm fast enough. No, I wasn't. Now we can see that certificate and certificate request, that there are two certificates, one for the backend and one for the front end. And Cert Manager as well created the certificate requests in the background. So one for backend and one for front end. I think the challenge should be gone already because it's really quick as soon as it creates the challenge and it gets acknowledged by Let's Encrypt. It disappears, but the certificate and certificate request, they stay. And with those, we can do get secrets. You can see that there are two new secrets. They are now 56 seconds old. And those secrets now contain the staging certificates for their domain. We can get the contents of them. As you can see, it's quite big. It's a base 64 encoded file, the TLS cert, and the TLS key, and some metadata that is maintained by Cert Manager. As you can see, it's, for example, for this domain, and it uses the Let's Encrypt staging issuer. And now, if I go to my browser, just a second, I will do it in a new incognito window to avoid any issues, hopefully. I need to find a way on integrating a browser into my Visual Studio Code. Okay, I hope you can see my screen. Now this is my Chrome. I visited the front end again. As you can see, this is insecure. That's what I wanted to do. We can see the whole chain, and now I should be able to see that it's a staging certificate. It's clear. It's the Let's Encrypt staging. They are not trusted by default by every browser. And if we do this as well for the backend, we can see it's also available.
We don't see much. We just see the browser window with nothing else. I don't know.
Oh,
maybe you're looking at another window.
I'm sorry. Screen sharing was stopped. Oh, okay. I'm sorry. Just a second.
Maybe try sharing the whole desktop, and this way.
Yeah, I have a white screen, so this might be an issue, but I will try.
Okay.
Let me try with Chrome again. Now you should be able to see the connection issue that is
an
invalid certificate. Right. So now this is the Let's Encrypt certificate from the staging. We can of course trust it, but it's still insecure. But at least we could prove that this is managed, or this certificate was created in an automated fashion by Let's Encrypt. Okay. So now I have to go back again. I'm sorry for this switching. I was planning to do this in the Visual Studio Code. Now, if we want to go to production, we just have to switch the annotation from Let's Encrypt staging to the Let's Encrypt prod issuer. We can do this again with applying the production ingress, and in the end, it will just change the issuer. And now, if we do get certificate and certificate request, we see that there are now two more requests, both for prod. They were just created a few seconds ago. Maybe the certificate, yeah, they are already ready. Maybe the challenge is already still there. Challenge, okay. No, it's gone. Okay, so that means our certificate should be available. We can check this as well by using the Kubernetes events. Now my font size is too big. Okay, here we have like the history of what happened in the background. We can see that, for example, here 50 seconds ago, Cert Manager was creating a new certificate request for the front end, and then it creates an order for Let's Encrypt, and then it was issuing it. Okay, now it seems, yeah, issuing certificate secret as previously issued by Let's Encrypt staging. So it understands, okay, it was previously a different issuer. Now it uses another one. And then we can see that the orders for backend and frontend are finished. And then a certificate fetched from issuer successfully. So that means our certificate is available. And now if I go to my simple browser, I hope it works now from this one. Correct. Now it's really HTTPS, but I believe I will have to switch to Chrome again because the simple browser is just too simple. Now I just need to refresh this one. And as you can see, my certificate is valid. I can go to the details and it's issued by Let's Encrypt US. Same for backend. Huh? Maybe the demo gods. Okay. Maybe it's not up to date already. Okay, I'm sorry for this. I tested it a few hours ago, so quite interesting. But I hope you have seen with the front end how it works basically. How I would debug this problem is now to go into the details. So we went through the events. So it should be finished, as you can see here. But what we can do is, for example, get the certificates, and then we can describe them. Then like app-backend-cert. Then we have a short history of the events again. It looks fine so far. We're using private key. New request certificate was issued. Should be able to see that this it is using the app Ingress. That's fine. The issuer ref, it's let's encrypt prod. And certificate is up to date and not expired. Maybe it's not reloaded by NGINX already. That could be the case. Okay, but yeah, I hope you've seen how it could work. And now I will go back to the slides. First demo that was not completely successful in my career. Just a joke. Okay, now I'm sharing my PowerPoint again. And now to the end, I want to share a few words about how we use NGINX Ingress and Cert Manager. Like one of the applications that we run or that we develop is this one. We use .NET Core in the backend, React-based front end. Our application is built with a DDD approach, so domain-driven design as the architectural flavor. CQRS for scalability, so we have a command and a query API, and we use event sourcing for auditability. We have around about 5 executables currently. The number is increasing by time, but the last time it was around 5, plus a few jobs running inside this. And this application runs on Azure Kubernetes service, and there we use NGINX as our Ingress controller in the same setup that you have seen, just with, let's say, more details in its configuration. For example, the routing, it's a bit more enhanced. We have a few more, let's say, cluster services that we need to maintain the cluster UD or OPA. And then, of course, Cert Manager. So we use this setup with Let's Encrypt to issue our certificates. The good thing is a Cert Manager issues the certificates from Let's Encrypt, and it automatically rotates them as well. So it waits, I think it's the default time is 90 days, the validity, and after 60 days, the certificate gets rotated. And so we don't have to care about it. And yeah, the setup it's quite simple. We do everything like in AKS except of persistence. We put this out of the cluster and use, for example, managed identities on Azure to access the persistence or the secrets inside the key vault. So no secrets inside of our cluster except the TLS certificates for TLS termination. And a few takeaways. I think Cert Manager is one of the go-to projects in combination with a Ingress controller. No matter which one, you can do this, of course, with the official NGINX Ingress or Kong or whatever. There are more out there. And Cert Manager is really flexible, and you can use it for a lot more use cases, for example, for cert rotations of the Linkerd data plane. And it's a quite handy. For debugging, we've seen it's not perfect, or maybe my demo was just not perfect. Usually, if you have a development cluster, I think with events and kubectl describe and then the CRDs of Cert Manager is the simplest way to get the details. Or if you're more in a production environment, the logging system. Usually, you put everything that's gets logged in the cluster into the logging system, and then you can analyze what Cert Manager is doing there. And from backup and disaster recovery, I think there are basically 2 ways to do this. One is with backupping the custom resource definitions, for example, the certificate resource that we have seen. You can do this with many backup tools. To just back up the Kubernetes resources and then apply them on a fresh cluster again. There are some details to consider. At least for me, the easiest way is to just reissue a certificate after a restore. So let's say you really have to run a disaster recovery and just build your cluster from scratch. It's quite easy to just reissue a certificate because Cert Manager does it automatically, and you can just apply all your Kubernetes resources. And so it's really handy to do a restore like this. The only dependency that you have is, of course, that Let's Encrypt has to be up and running. Okay, and yeah, that's it from my talk so far. Of course, I'm from a company. We are hiring, trying to find good stuff. And so if you're interested in such projects, feel free to apply. And yeah, if you have questions, now's the time.
Excellent. And it turns out we do have a question. So Vlad is asking, how can you use staging certs in a useful manner? Since it is self-signed, the browser refuses it, and any API calls through browser fail as well, because you cannot set exceptions for them easily.
Mm-hmm. That's a good question. So at least for my cases, I always use the staging certs just for proving that my Cert Manager works properly and that I can issue all the certificates, that I can go to production without running into, for example, like being blocked by Let's Encrypt because the challenge cannot work or whatever. Maybe, well, usually you have a firewall in between and all the stuff that could stop the process from working. That's the only reason for me to use the staging environment, just to prove that my system does what it should do. And then I go to the production certs. So all of our environments from development to production use the Let's Encrypt production issuer. So we don't have this problem of browsers not accepting the certificate. It's just temporarily for a few hours, and then we run with production certificates.
And Vlad again is asking on the chat, so you don't really use staging certs?
Yeah, just for the beginning to see that the system is working properly, and then we switch to the production certs or the production issuer from Let's Encrypt.
Cool. So Vlad, does this answer your question? Yes, excellent. Any other questions? Somebody else? Maybe you would like to share your concerns or some experience? Yes, another question from Vlad. How do you combine authentication and authorization with NGINX?
That's an interesting question. So I think there's the possibility with the open source NGINX Ingress to do, for example, the OpenID Connect, like to verify the signature. There are plugins for this. I think you can use, there was one open source project, I think it's OpenID Connect Proxy, something like this for it. But in our case, we are not doing it inside of NGINX. NGINX is more for the routing and TLS termination for outside and the buff and stuff like this. And from the inside, we do the authentication and authorization in our application code.
Cool. Excellent. Thank you so much. And thanks, Vlad, for the great questions. By the way, it's great to have excellent questions tonight. That's really cool. Thank you so much. Somebody else? Maybe something else? Maybe Vlad, you still have something you would like to ask? Please feel free to do so.
Maybe one thing in addition to the last question about authentication authorization. I'm not that deep into the, let's say, official NGINX Ingress, so maybe this one has something out of the box that you could use. But I know that the community one is, let's say, not advanced in, or not that advanced in this case. That's why we just do it in the application.
Right, absolutely. And another question. So you're doing A&A for each service individually?
No, not really. We are doing. We have like a soft load balancer in between, a software load balancer in between that does the overall let's say, initial authorization, but it passes the remainder to the backend, so to the actual business logic services that then check the claim again. There is the service-to-service authentication. So our services are not really calling each other. We're doing everything via event-driven, so a service bus in the end. And so they use their own principles to authenticate against a service bus, for example.
Great. I've just asked Vlad on the chat whether he would like to ask maybe directly something else through your microphone. I can enable that, of course. So, and of course, if any of you would like to do that as well, please let me know to have an open conversation. Otherwise, let's go. I would, but I don't seem to have an option to enable the mic. No, because I have to do that for you. So I'm going to do that right away. So basically allowed to talk. There we go. Vlad, you can ask your questions openly now.
Thank you. Well, it's unfortunate that others are not asking questions, I guess. I would very much.
We cannot hear you very well. Maybe you should change microphone. Maybe in your Zoom client.
You're far away, yeah.
Is this better?
Definitely.
Okay.
Thank you.
I have no idea why the headphones are not working. Yeah, very cool that about the architecture, and I would very much like to know about how others do it. Doesn't seem to be much of a discussion, unfortunately, but that's nice. And do you also, or does NGINX create multiple load balancers for each of the ingresses or each of the ingress resources?
Mm-hmm. No, it does not. In the end, as soon as you deploy an Ingress controller, it creates a Azure load balancer. So in the end, it's a Kubernetes service object of type load balancer in the background that allocates this public IP. And all the hosts are managed with this same load balancer, Azure load balancer public IP. As soon as you deploy another Ingress controller, you get another load balancer with a different IP. But there are more combinations possible. But at least in our cases, we do everything over one load balancer because we have no need currently for multiple Ingress controllers.
And is this only the case for Azure? Because I didn't have the same experience at AWS.
It works similar with other cloud providers. So all of them have like a layer 4 load balancer that gets created as soon as a Ingress controller is created.
That is interesting. Because whenever we created like an Ingress, it automatically created like its own load balancer, which costed it like horrible amount of money. That was unfortunate.
Okay, which cloud was it?
AWS.
Okay, yeah, that's a good point. I don't know the AWS implementation with EKS. I'm mainly on Azure, so that's quite interesting because at least from my point of view, all the layer 4 load balancers should be more or less cheap as long as there's no traffic on them.
And so and how do you do backups of the certificates? You mentioned the CRDs, right? So that would be some other external tool.
Yeah. So it's a good question, but I'm the one that uses the second point for backup is just reissue the certificate because our clusters are designed to be really stateless. So there's nothing inside the cluster that we need to back up, and we just redeploy our stuff. So we have a good working CI/CD setup that we can just reissue all the things that we need to get up and running if we, I don't know, lose a certificate or our cluster is broken. Because I think we have everything in Git or in our pipelines that helps us to restore our state. And for our persistence, we have the Azure PaaS services that do backups on their own that we can restore then afterwards.
And did you never run into problems with the limits of Let's Encrypt?
No, because as soon as Cert Manager issues the certificate, it just manages or it observes if it's going to expire, and then it will do the reissue or rotate the certificate, and it doesn't do polling or all the stuff. That's the reason why I say I use the staging certificates to check if there are some inconsistencies, because in another project I had an issue that we were using CQRS as well, and we were exposing the services directly via Ingress, so the command and the query side. And it's quite obvious that you just need the query side because it's a GET request for Let's Encrypt to get the details from Cert Manager. And I was just misconfiguring our Ingress with the CQRS setup. And so I had some issues. And so I could use the staging environment to just verify if my Cert Manager Ingress setup works. And then I haven't had any issues with production because as soon as I did the switch, it was running out of the box.
Okay. Interesting. Because I was trying to use the staging certificates, but they were somewhat unusable. So I switched to production, but then I accidentally deleted the certificates like 5 times, and I got locked out for a week or 2 weeks, and I had no certificates.
Oh, okay, interesting. Okay, I never had to delete the production certs.
Maybe not the production, but even on development. Like I use the production certificates in development because otherwise the testing of the front end was just pain. But whenever I think I was restarting the cluster, like I restarted it 5 times and that was fine. But on the 6th time, it refused to give me like the certificate. So I went to the forum and they told me, oh yeah, you just need to back the certificates up because creating the certificates is expensive because they are using some special hardware and that I should not be abusing the service, unfortunately.
Yeah, it's true that creating certificates it's expensive. That's why I, let's say, try to make sure that everything works on staging, that I have just the normal rotation interval on production. But it's interesting what you say. But I have to say, at least in our environment, I never had this problem because it was just running once to issue the certificate, and then it was just reissuing it every 60 days.
And about you mentioned that the development or staging and the production are using different labels or annotations, right?
Yeah, to reference. So we have to distinguish between our own environments and the Let's Encrypt environments. So for the Let's Encrypt issuers, there's just production and staging. But I have in my environments dev test prod or more. And there I can use staging and production. So I can use both issuers in each of my stages. But usually I start with staging, see if everything's correct, and then I switch to Let's Encrypt production also for the development. Yeah.
I suppose I answered my own question, but the original question one was supposed to be, and how do you have multiple files for these various annotations, or what type of configuration are you using?
We use Helm to roll out our applications, and we just do an override for each stage.
And about so Ingress or NGINX Ingress Controller allows you to create like open traffic for ports 80. But is there an option, or somehow is it possible to create openings on different ports using ingresses?
That's interesting. It's a good question, and honestly cannot answer it out of the box. Because let's say from Ingress, it's like standard for HTTP traffic, which is just port 80 and 443. I don't know if there's an option. I believe there are some hooks inside the NGINX Ingress Helm chart. I would believe so, that there are some hooks, but I cannot say it for sure. I would have to go into the docs and look.
Yeah, okay. Yeah, because we were also we wanted to like expose what do you call it? FTP, and dude, that was such a pain.
Okay, that's something different. So Ingress is really made for HTTP traffic. So it's more or less by design, not for, let's say, for example, also plain TCP traffic. There are Ingress controllers that support TCP traffic or maybe different traffic for different protocols. I think the official NGINX should be able to do this, but then you will need to use the custom resources provided by this Ingress controller, because the official Ingress standard is just for HTTP traffic.
Okay. Nice one. Thank you. I don't have any more questions.
Good.
Okay. Thank you.
Excellent. Thanks a lot, Vlad. Great conversation. Thanks a lot, Marc, for the answers. Right before we leave, I'm just going to ask Marc if you could stop sharing. I just have one more slide I would like to share.
Okay. Just here you can see now the certificate was rotated. I don't know. Maybe it was a timing issue.
Exactly. Sometimes you have to wait. I have that with my demos all the time, so it's
That's the demo gods. Okay, I stopped sharing.
Absolutely. And here we are. So if you like this meetup, I hope you did. And thanks, Marc. It was great. We are going to have next week our Cloud Native Computing Meetup, which we hope will be the last one using this format. We have planned as well one for February 24th, which should be in person, should be with beer and pizza. Well, like it should be to have these kind of conversations. So I invite you all to sign up and to join us next week and in February through our meetup.com page to the Cloud Native Computing Switzerland. And there's much more events that we organize or where we participate. You can find all of that in vision.ch/events. And once again, thanks a lot, Marc. It's been great having you back, because you've already spoken once at the CNC meetup and we really, really enjoyed your presentation. So here you are back, and maybe one day we'll have you back again on the CNC meetup. Who knows? You are always welcome. If you would like to present in February, so for next week, we are full in terms of a program, but in February, we still have 2 slots. So this is open to all of you who attended today, this presentation. If you would like to talk about your favorite CNC cloud native computing technologies, please feel free to send me an email, adrian@vision.ch, very simple, or use the contact form on vision.ch. We will be super glad to have you. The stage is yours in these events, of course. Cool. Thank you so much, everyone, for attending. Thanks a lot, Vlad, for the great questions, the great conversation. Thanks, Marc, for a fantastic presentation, as usual, even if the demo bots sometimes are a bit picky and you had to wait a few minutes for things to happen. But it did happen, so it was working. So that's cool.
Yeah.
Thank you so much, everybody, and have a nice evening and see you soon. Bye-bye.
Thank you. See you.